Hello everyone, welcome to my channel where we are learning DSA concept wise. So let's have a look at today's problem. So today we will look at DFS traversal of graph, that is depth first traversal. So first let's understand what is DFS traversal. In DFS traversal we traverse the graph depth wise, means we start from a node. First we traverse to the depth of that node in one direction, then we move to the next neighboring nodes. So let's understand depth first traversal with an example. Suppose we have this graph. So let's see how DFS will work on this graph. Let's take 1 as the starting node. So here we can see that from 1 we can go either to 2 or 3. So as I already mentioned that in DFS first we traverse in the depth of one direction, then we move to next neighboring nodes. So here first let's move to 2 from 1 and let's write the sequence of the traversing nodes. So let's write 1 and now from 2 we can move to 5. Let's write 2 and from 5 we can move to 8. As from 8 we can't move anywhere, so let's write 8 and from here we will traverse back. As we don't have any another neighboring nodes of 5 and 2, so we will reach back to 1. Now from 1 we will move to 3 and let's write 3. And now from 3 we can see that we can go to 4, 6 and 7. Let's move first in the direction of 7. Let's write 7 and from 7 we can move to 9. As we don't have other childs for 9 and 7, so we will backtrack to 3. And from 3 we will move to, let's say, 6. Now in last we will move to 4. So this is the DFS traversal of this graph. Now first let's understand the pseudocode, then we will implement the actual code. So for DFS first we need the graph. Graph we can store either in 2D matrix or in adjacency list. Let's have an adjacency list here. Now we need a starting node. Let's take 1 as the starting node. And let's take number of nodes n. So here we need one visited array. It's a Boolean array of size n. Let's understand why we need this visited array. So as in DFS, we move to the nodes, and if we look at 1, so from 1 we can move either to 2 or 3. Suppose we move to 2. So when we are at 2, so the neighbors of 2 are 1 and 5. So we from 2 either we can move to 1 or either 5, but 1 is already visited. So to keep track of the visited nodes we need a boolean array to avoid the visiting nodes again, because otherwise we will stuck in an infinite loop. So that's why we need this visited array. This can be either a integer array or boolean array. We just need to keep the track of the visited nodes. So if we take it as a boolean array, so we can mark the visited node as true or false, or if it is an integer array we can mark the visited node with 0 and 1. So now let's create a function DFS where we have the graph and the node. So our first step is to mark this node as the visited node because we are already on this node. So let's mark it true. Now we can print this node or we can store this node in an array as per our requirement. So now we need to visit the neighbors of this node. So for this we will run a, let's say, for loop, and we will visit the neighbors of this node. And here if we will check if neighbor is not visited, Then we will call the DFS recursion call on this neighbor. That's it. So this is the DFS traversal of a graph. So here first let's understand how the adjacency list work for a graph. So let's try to create the adjacency list for this graph. So the adjacency list for this graph will look like this. For 1 we have these two neighbors. For 2 we have 1 5. For 3 we have 1 4 6 and 7. And for 4 we have 3 4 5. We have 2 and 8. For 6 we have 3, the neighbor. For 7 3 and 9. And for 8 the neighbor is 5. And for 9 the neighbor is 7. So here if we see, for each node we have a array of neighbors. In this way the adjacency list stores the graph. Now let's implement the code. So here we have given the graph as adjacency list and number of vertices as v, and the starting node is the 0th vertex. So what we need here extra, one boolean visited array. Let's say the size v. Actually the size of this visited array depends on the starting index of the vertices. If the starting index is 0, then the size will be v, number of nodes. Otherwise you can take it as v plus 1 if the starting index is 1. Now to store our answer we need an array list of integers. Let's take it as answer and new array list. Now we will create a DFS function that will accept four parameters. The first parameter will be the adjacency list, the graph. The second parameter will be the node. Third parameter will be the Boolean visited array. And the fourth parameter, we need this array list to store the answer. So in this function, our first step to mark this node as visited node. So we will mark it true. And we will store this node in our array list. Now we will run a loop over the neighbors of this node, and we will check if this neighbor is not visited. Then we will call the DFS recursion call on this neighbor. And now we will call this DFS here, and we will pass our arguments. Starting node is 0 node, Boolean visited array. This should be visited, and the array list, and we will return our answer. Let's try to compile this. So this is fine. Now let's submit this. So this is done. Now let's understand the time and space complexity of DFS. The space complexity will be big of V because we are using this visited array. For time complexity, we can see that we are visiting each vertex once. We are calling this DFS only once for each vertex. And for each vertex, we are calling this for loop. And this loop we are calling for the number of edges corresponding to that vertex. So in case of undirected graph, we can say that the time complexity is V plus 2E. because we are traversing each edge two times. And in case of directed graph, the time complexity will be V plus E.